Okay, our first speaker is at the forefront of a really exciting area in medicine called aging, which will apply to all of us sooner or later. He has been at the forefront of it for a long time. He focuses on understanding the biological mechanisms of aging for health span improvement. There are a number of our entrepreneurs in the audience that are working on aging, so I think you'll get a kick out of this as well. He's published over 250 papers on aging biology and is currently the Chief Scientific Officer at Optispan Geroscience. So please welcome Matt Kaeberlein.
So it's, I don't know how I should feel about being introduced at being at the forefront of aging for a long time, because another interpretation could just be that I'm old, which is ironic considering I study aging. So it's a pleasure to be here. One of the interesting things about having been in this field for a long time is that, 10 years ago, if I'd given this talk, probably almost nobody in the audience would have heard of aging or longevity. And now I'm guessing many of you have heard of aging or longevity. And depending on where you get your information and the podcast that you listen to, I would guess about half of what you've heard is probably accurate. So what I want to do today is give you sort of an introduction to the field, some of the questions that I think are important. I've been asked to touch on several topics. So I'm going to go a little bit fast through the introduction, but the slides are available. If anybody wants to get them afterwards, go to optispan.life, COSLA 2023. You're welcome to use them in any way that you would like. So I want to start by taking a step back and really just talking about the way that we think about health. And I would certainly suggest that what we call modern medicine, I would actually say it's 20th century medicine, really has approached health from the perspective of disease. So you may hear me use this phrase, reactive disease care, a few times today. There's no question that we have approached medicine from the perspective of individual diseases in silos. This is true in healthcare, it's true in biomedical research, it's true in drug development. And one of the consequences of siloing diseases individually is that we typically wait until people are sick with one or more diseases, and then we optimally try to cure those diseases, but in reality what we end up doing is treating the symptoms most of the time. And so, again, you'll probably hear me say this a couple more times. We have been very successful at keeping sick people alive. We have been less successful at keeping people healthy. And this, I think, is the fundamental challenge that we face, but also opportunity as we go forward. One of the consequences of focusing on diseases in isolation is that we lose track of the sight that all of these functional declines in diseases that are the major causes of death and disability in developed countries share at their root a single greatest risk factor. And I would argue a single greatest causal risk factor, and that is the biological aging process. And it's not even close. So just to give you a feel, your risk of developing heart disease goes up about 2 to 3-fold if you have high blood pressure. And that's true for other risk factors that are commonly talked about. Your risk of developing heart disease from 4 decades of biological aging is 40-fold. Your risk of developing Alzheimer's disease over that same time period goes up 300-fold. So we're talking orders of magnitude difference in risk. And one of the implications of this idea that it's biological aging that underlies all of these diseases is that if we can understand that biology, we can actually start to manipulate it in a way that may slow the onset and progression of many, maybe all of these functional declines and diseases simultaneously. So this is the promise of what I call 21st century medicine. If any of you listen to Peter Attia's podcast, he calls medicine 3.0. The idea here is that we are on the cusp, I think, of having an opportunity to shift healthcare away from reactive disease care more towards keeping people healthier longer. And in part, that will be through targeting the biology of aging. So that's kind of the big picture that I'm going to present you with today. You can ask the question, what would the impact be again, from these two very different approaches. Reactive disease care is about curing disease in sick people. If we could be successful at curing individual age-related diseases, you can ask the question at the population level, what would the impact be on life expectancy? And people have done that. This is work from J.L. Shansky originally, simply asking the question, if we could cure heart disease or cancer, what would the impact be on life expectancy for a typical 50-year-old woman? It turns out it's about 3 years for each of those diseases. Even if you could cure both, I'm talking about all forms of cancer, all forms of heart disease, it's about 7 years. And the reason for that, when you actually think about it, is pretty obvious. It's because if you only take one disease at a time out, you still have all those other diseases of aging increasing exponentially. And if cancer and heart disease don't get you, one of the others will. Now, we can ask the question, what would the impact be of slowing aging? And admittedly, this is a hypothetical at this point. I can't tell you that we can do this in humans. What I can tell you is we can do this pretty routinely in laboratory animals, including small mammals like mice and rats. So if we could slow aging by 30%, which again is pretty routine in laboratory animals, what would the impact be on life expectancy for that same 50-year-old woman? It turns out it's much bigger. It's about 2 to 3 decades, with the added value that those extra years are predicted to be spent in good health, free from chronic disease and disability. So this leads to the concept of health span, which I think is really important. And so I'm not going to define a bunch of terms, but I want to give you 3 terms that I think are important to appreciate. Lifespan's easy, right? Birth till death, easy to measure, no ambiguity about what lifespan is. Health span's a little bit more of a squishy term. We don't have a consensus definition for health span. And the reason why I'm explicitly saying that is you will hear people talk about, we've extended health span. And I get a little bit uncomfortable with claims about extending health span because it's hard to statistically say you've done something that you can't really measure quantitatively. But I think health span's a really useful concept. And I think one way to define health span is the period of high functioning life. And again, recognize health is not binary. It's not like you go from being healthy 1 second to unhealthy the next second, okay? But I think this is a useful concept, and one way to define high functioning would be the absence of chronic disease and disability. So the goal really here is more about pushing the diseases of aging back as far as possible and maximizing health span than it is primarily about extending lifespan, although the reality is when you target the biology of aging, you do both. And again, I'm explicitly calling this out because I want to differentiate from reactive disease care, 20th century medicine. I think we've been not too bad at extending life expectancy. What we've actually been quite successful at is keeping sick people alive longer. We haven't been so good at extending health span, and that's a really important thing to understand. And then I just want to define the word geroscience for you, because I think this will start to permeate the collective consciousness a bit more. That's just referring to the biology that connects aging to functional decline and disease. And again, if we can understand that biology, we can do something about it. Okay, so I was asked the question, is aging solvable? And my answer is, we're starting to, right? We've made a lot of progress at solving the biology of aging, and there are lots of ways to appreciate that. One way to appreciate that is through the lens of the hallmarks of aging, which again, some of you may have heard of. This is based on a review paper that's now about a decade old, where the authors attempted to kind of synthesize the consensus factors, mechanisms that drive biological aging across the animal kingdom. And they came up with 9 hallmarks. This has been updated depending on who you ask. There may be 11 or 12 hallmarks of aging today. It doesn't really matter what they are for the purposes of this talk. What I want you to understand is we understand a lot now about some of the fundamental mechanisms of biological aging that seem to be shared across all animals, including humans. One of the important implications of that is that each of these hallmarks, potentially even in isolation, can be targeted therapeutically to have a positive impact on the biology of aging. The other point I want to make about the hallmarks, though, is that they're not acting independently. There is a network underneath these hallmarks that connects them, and that's what I went forward. That's what the arrows in the middle there are meant to illustrate. So we don't know everything about that network at this point, okay? We're still learning the details of that really complicated system. We know some of the nodes in that network that seem to be useful for targeting the biology of aging, and I'm going to talk about one of those in a minute. The other point I want to make, though, is that what we really don't know in the field, and you won't hear too many people in the field talk about this, what we really don't know is what we don't know. And I don't know how much of the biology of aging we actually understand today, but my intuition is it's a lot less than many of the more optimistic people in the field believe that we know. I would guess that our understanding of the biology of aging is somewhere akin to the understanding of the known world in 500 BC. And so this is a map of the known world in 500 BC on the right. You'll see there's sort of this nebulous-shaped Europe, which kind of looks like the shape of Europe. There's a shape of Asia that looks nothing like Asia, and then there's very big Libya, and then there's the ocean around it, and if you sail too far, you're going to fall off the edge of the earth, okay? That's my speculation, is that there's a lot more we don't know than we do know. And the reason why I'm saying this is because I worry a little bit that one of the limitations in the field right now is that the field has become somewhat narrowly focused on what we think we know. It's actually become a little bit difficult to study things that are outside of the hallmarks of aging because of this construct. And I worry a little bit that this is slowing down progress by focusing so much on the little bit that we do know and not very much on what we don't know. I would argue that most of the field is looking under the lamppost right now, not looking at what we don't understand. We're focused on the hallmarks, and you'll see a lot of people also focused on clocks. And I'm going to use the word biomarkers maybe more than aging clocks, but that's something a lot of people are excited about now. And I'm enthusiastic about clocks as well, but the clocks can only measure what you know. They can't measure what you don't know. And again, I'm a little bit worried about what we don't know. I would also simply note that while there's been a ton of progress in understanding the biology of aging, there hasn't been as much progress in sort of game-changing new interventions to target the biology of aging with large effect size. And I think this is an important concept, again, to appreciate. So you'll hear people talk a lot about caloric restriction. That's the most effective intervention for slowing aging and increasing lifespan in laboratory animals, up to about 60%. In mice with about a 60% reduction in caloric restriction. That's the biggest effect. That experiment was done in the 1980s. We've known about caloric restriction as a longevity intervention since the 1930s, okay? The most effective drug for increasing lifespan and health span in laboratory animals is rapamycin. I'm going to talk about rapamycin in a minute. That was first discovered in 2006 in yeast and first shown to extend lifespan in mice in 2009. So I think it's a legitimate question to ask, why hasn't the field done better than rapamycin in the last 15 years? And I would argue in large part it's because nobody's really looking. So I'm personally very interested in finding interventions of large effect size that can really move the needle. And I would like to see more people really focused on outside the lamppost rather than looking under the lamppost. And so one of the ways that I'm approaching that is with some technology that we developed in my laboratory. We've spun out a company called Aura Biomedical, really with the goal of trying to explore the unexplored. And we are proposing a 1 million molecule challenge to try to test 1 million interventions for their effect on lifespan in commonly used laboratory animals. And I can guarantee you we're going to find things that are better than rapamycin. We're going to find a lot of things that are better than rapamycin, and I'm pretty excited to see what those things are. Okay, so what do we know? We know aging biology is real, okay? We understand some aspects of aging biology. We know it's modifiable. So again, there are multiple ways in the laboratory we can tweak that biology to increase lifespan and improve several metrics of health span, okay, in laboratory animals. We also know it's more effective than targeting individual diseases, and I already took you through the math there. We know some key nodes in that network, and among those nodes, I think some of them have pretty significant therapeutic value, okay? And I think that we're likely to be able to have an impact on health span in people by targeting some of those nodes. And I'm gonna, in a minute, do a little bit of a deeper dive on one of them, which is called mTOR, for the mechanistic target of rapamycin, and a drug, rapamycin, which has been shown, again, in laboratory animals, and we're starting to get some hints in people to have positive effects on health span. But I was asked to comment on where the hype is ahead of the reality in the field, and that's both a pretty easy question to answer and a difficult one, because I think you can point to a lot of different things in the field where the hype is ahead of reality, which is true in many fields. The three that I've chosen to call out specifically here are by no means an extensive list, but I think there's some of the ideas that lots of people are thinking about right now, and probably many of you in the audience have thought about as well or heard about. I think, and I'll also mention Rich Miller, who's at the University of Michigan, and myself just earlier this week did a webinar for genetic engineering and biotechnology news on this topic, separating the science from the snake oil. It's available online if anybody's interested, where we do a little bit of a deeper dive on some of these. So supplements, probably a lot of you, maybe not a lot, some of you are taking supplements that you've heard about that may affect aging, anti-aging supplements, longevity supplements. It's really hard to know which of these supplements have value. So what I would say is I don't personally have a lot of faith in most of the over-the-counter supplements that are being marketed for their potential effects on the biology of aging. Some of them are pure snake oil. Some of them have some science to support them. What I would say, though, is I don't think any of the natural product supplements that are out there now are really going to move the needle as much as people are hoping. Certainly, I would not suggest that any of them are going to make up for a poor lifestyle, for example. So while I'm not saying you shouldn't take any of these supplements, what I'm saying is I don't think they're going to really have a big effect. We'll talk about risk-reward in a little bit, and I think you could make a rational argument that the potential reward outweighs the risk for taking some of these supplements, but it's really hard to point to any of them with a lot of confidence and say, yep, that's what you should be taking. That's really going to move the needle. The other question that I'll pose is we don't really understand combinatorial interactions for a lot of these supplements or longevity interventions in general, okay? And that's an area of weakness, I think, in the field. We can say one drug by itself may have a positive effect, but we don't really know a lot about what happens when we start to combine things. Biological aging clocks is another area where I feel like the excitement and enthusiasm has gotten a little bit ahead of the science. So the idea here is pretty straightforward. Biological aging clocks are meant to measure the rate of biological aging using different types of information. So you can do that phenotypically. We can all look at a person to some extent and develop our own biological aging clock and guess their biological age. The clocks that people are excited about now measure molecular information. And one type of molecular information that people are most excited about now are these epigenetic aging clocks. Okay, you've probably heard of those. The only point I want to make is having tools that can measure biological aging is very, very important. We need those for a bunch of reasons. We need those in order to test interventions. We need those to do personalized medicine. We need those to predict future health risks and disease outcomes. But I think it's important to appreciate we don't have any clocks today, right now, that there's confidence that they are actually reporting on those things in a actionable, meaningful way. So you can go online. There's a bunch of direct-to-consumer companies that will measure your epigenetic age. We don't yet have confidence what those things are telling us, what their precision is, what their variance is. And all of them are only measuring one sliver of biological aging. So I just think that's important. If you want to use that for entertainment purposes, great. If you want to use that to actually inform yourself about your future health outcomes or your mortality risk, I'm less confident that they're useful in that way. And epigenetic reprogramming. I don't have time to dive into this. Probably many of you in this room have heard of epigenetic reprogramming. Some of you might be actually studying it. This is an area of the field that has immense promise. The idea here is that we know that the epigenome changes with age. There are some tools now that can be used experimentally to reverse that. The question is, what impact will that have on health and longevity? And that's a complete unknown. You will hear people talk about reversing aging. That's, in my view, I was going to say nonsense. It's a poor choice of words, I would say. We don't know at this point how effective epigenetic reprogramming is going to be from a therapeutic perspective to have a positive impact on the biology of aging. At this point, there's some evidence in mice that you can improve function in some tissues and organs using epigenetic reprogramming. So far, there's no evidence that you can even do as good as rapamycin, okay? So I'm not going to say that you can't. There's no data yet demonstrating that epigenetic reprogramming is even as effective as rapamycin in terms of increasing lifespan and health span in mice. So I prefer to be data-driven, and that data doesn't exist yet. So we don't know. So again, I think it's fair to say the hype has potentially gotten ahead of the reality. So I'm going to talk about rapamycin very quickly. Rapamycin is a pretty interesting drug. I would say it's the current best-in-class longevity drug. It's not a miracle drug. I certainly wouldn't say that. But we know a lot about rapamycin, and it has some pretty exciting effects, I would say. So it's actually been FDA approved for more than 20 years, so we know a lot about its use in humans. It is the most effective longevity drug to date in animal models, up to about 30% increase in lifespan in mice. One of the important things about rapamycin is it actually works in laboratory animals starting in middle age. This is really important because if you think about a translational intervention for health span and longevity, you don't want something that you have to start giving to teenagers, right? You want something that you can potentially start treating middle-aged people with. And that seems to be the case with rapamycin. And importantly, it doesn't just extend lifespan. In pretty much every tissue and organ where people have looked, and there are a bunch, some of them are shown on the left, rapamycin has been shown to delay the declines that go along with aging, and in a few cases, actually reverse the functional declines within about 6 to 12 weeks. So the 4 that are shown in red are the places where there's the best evidence, again, in mice. You can start treatment in middle age, and within about 6 to 12 weeks, actually see functional improvements in the aged tissue or organ. That's true in the heart. Several labs have reported this, and there's some evidence even in pet dogs that this is true. It's true in the immune system. You can restore the ability of the aged immune system to respond to a flu vaccine. It's true in the female ovary. This is quite striking. Actually, you can see morphological rejuvenation of an atrophied ovary in mice, and there are now some clinical trials in people for premature ovarian failure. And it's true in the oral cavity. We've shown in my lab you can reverse periodontal disease in aged mice. So again, from a translational perspective, that's quite powerful. You could imagine clinical trials designed to actually measure some of those endpoints where you actually make things better rather than trying to see a change in the slope of the decline. And you can extend lifespan with a transient treatment in middle-aged mice. So this is, again, work from my lab several years ago where we took 20-month-old mice. That's about the mouse equivalent of a 60, 65-year-old person. We treated them for 12 weeks with vehicle or rapamycin, and then we just asked the question, what's the effect on survival? And in this particular case, it was about a 60% increase in remaining life expectancy. If you think back to that 50-year-old woman that I alluded to earlier, again, that's about 2 decades for a typical 50-year-old woman. So I have no idea whether the magnitude of effect is going to translate and whether it will translate linearly if it does, but potentially pretty significant impacts on life expectancy from these kinds of geroscience interventions. Okay, will rapamycin work in the real world? I am confident it will work to some extent in the real world, but I don't know how well it's going to work or if the magnitude of effect, again, will be anywhere near what we see in laboratory animals. We are in the process of doing a double-blind, placebo-controlled, randomized clinical trial in pet dogs. Pet dogs share the human environment, live in the real world. We should know the answer to that in a few years. And there are, as I alluded to, there are now some small clinical trials happening for ovarian failure, periodontal disease, dementia. I think we'll start to get data from those clinical trials. And then we've recently wrapped up, and the URL is there for anyone who's interested for the paper, a study of people who are using rapamycin off-label. I suspect in fact, I know there are some people in the room who are using rapamycin off-label right now for its potential effects on health span. We collected data from about 330 people who've been using rapamycin off-label and some non-user controls. And obviously, there are lots of weaknesses in that data, but there's some interesting hints for potential benefits from rapamycin. And I think the other thing that's important is no real evidence for significant side effects. And I just want to say, I think there are tons of good endpoints for rapamycin clinical trials. I hear a lot, and I agree, we need clinical trials. We need to know the answer to this. I completely agree with that. We also need somebody to pay for it, okay? So unless somebody's willing to pay for these clinical trials, and there are lots of good endpoints to look at, we're not going to get that data. And so we're going to be left with small, underpowered clinical trials and anecdotal data from people using rapamycin off-label until somebody steps up and actually pays for the big clinical trials. Okay, so where will we be in 1 to 2 decades? Now I'm going to speculate a little bit. I don't think there's any evidence yet that aging can be cured in the sense of you will no longer age, we can make you age in reverse, you will be immortal. I don't think there's any data to support that at this point. I'm not saying it's impossible. I'm not saying that shouldn't be the goal, but there's no evidence to suggest that that's likely anytime in the near future. And I just think that's important because some people like to make questionable claims. But I will say we already know enough to intervene in biological aging. And I put weekly, it's weekly in the sense of I've been thinking about this for a long time, and I'll tell you what I mean by weekly in just a minute. But I will say compared to reactive disease care, it's a pretty big improvement. I think we already know enough to do that. And I predict that in the next couple of decades, we will get to the point where we can move most people to where we think the species maximum lifespan roughly is, which is about 115 years. So to illustrate this, I want to talk briefly about this concept of the lost decade. I believe almost everybody today, 95% of Americans are giving up at least 10 years, it's probably closer to 15 years of healthy longevity. I think we can get that lost decade back for people today. Some of that is going to be through lifestyle changes, and some of that will be through the science of the biology of aging. And those things are interconnected, right? Again, I think that's important to appreciate. Most of the lifestyle changes that you've heard about that can have a positive impact on health are modulating the biology of aging. That's why I believe they have such a profound impact on health. So I think this is doable right now. I think where we want to get to is what I would call the longevity dividend. And we're not there yet. I'm not going to argue that we know enough today to do this, but I think we'll get there. And I think the science where it's at today, there's enough indications that we can mature to the point where we can push most people's health span out to match their lifespan and get that close to what we think is the species maximum lifespan. So we need second generation geroscience interventions and biomarkers in order to be able to do that. And this is where I'm focusing the next phase of my career. How do we get the lost decade back for people? And then how do we expand on that to achieve the longevity dividend? So what should you do now, right? I'm not going to give you the list of the stack of supplements and medications you should take. Sorry. Oh, and I will be around all day. So if anybody wants to talk to me offline, I'm happy to tell you what I think more specifically you should do. I do think you should invest in your health like it's your greatest asset, because it, by God, is. Okay, really think about the quality of your life when your health declines. Getting back to this idea of the lost decade, a life where you develop heart disease, kidney disease, diabetes in your 50s is a very, very different life than if you develop those diseases in your 80s, 90s, or never. So you should really be paying attention to your health. I see a lot of young people in the audience. You're probably not thinking about this yet, but you should be. Okay, so how do you do that? Number one, don't die. That's my rule number one of longevity. Don't die. How do you not die? Well, part of that is making sure that you don't have something that's going to kill you already. And I think this is where advanced baseline and preventative diagnostics play a role. This isn't geroscience. This is some of the tools that we have now to make sure that you're not sick. And we've got some pretty good ones. And as I've started to get into this world, I'm kind of shocked how few people actually take advantage of them. And I think there are lots of reasons for that. But I would say you should be thinking about advanced preventative baseline diagnostics today to make sure that you're not going to die tomorrow. Finding a good doc is really important, and that's really hard. And this is where some of my work at OptiSpan, I hope, will make a difference. So at OptiSpan, our goal is really to enable providers to practice science-based, friction-free, preventative longevity medicine. And so we're trying to build the tools to allow that. This is hard right now. There aren't a lot of doctors, especially primary care docs, that know enough about this space to really do it well. So I can't point you to those docs, but I hope I can help make a difference there. I also hate to say it, but lifestyle matters, okay? It's not, you can't just do whatever you want and expect to live to be 80, 90, in good health. Okay, so you got to pay attention to lifestyle. You need to educate yourself and find credible sources. This is also easier said than done. I will simply say there aren't enough credible sources out there in this field right now, but I hope there will be more soon. I will say, I've mentioned Peter Attia's name once already. I'll mention it again. I think Peter's one of the better sources in this area right now, so I can recommend him. And I think as a last concept I want to leave you with, because I just realized I'm out of time, I want you to think about risk-reward. I don't think we spend enough time thinking about risk-reward in the context of our health and our future health. Traditional medicine is very risk-averse, and most doctors are not going to consider that doing nothing has risk. I can guarantee you doing nothing in the context of aging has risk. We all know how it's going to end. And so we should spend some time thinking about what is the appropriate level of risk if the reward is to push the diseases of aging back 5 years, 10 years, 20 years. I would argue there is a level of risk that's tolerable if that's the potential reward. And I think that many of us in the field are working hard to educate medical providers, policymakers, FDA, to try to rebalance that risk-reward ratio. And I'll just leave you with, I think you should think about that for your own lives. Okay, what level of risk is appropriate for you for the potential reward of many extra years of healthy longevity? And so with that, I'll stop. I don't think I have time for questions, so thank you for your attention. And again, I'll be around all day if anybody wants to talk further. Thanks.